Chapter magnetic field due to electric current. The question says that a piece of a straight wire has mass 20 grams. So in the given data, we have been given mass is 20 grams. Convert this gram to kg. 20 into 10 raised to minus 3 kg. Levitated means it will be in the air. It will be suspended in the air using a current of 1 ampere. I is given 1 ampere flowing through it, and a perpendicular magnetic field B is in the horizontal direction. What should be the value of B? So the value of B, see, if it is to be levitated on the air, if it is to be levitated, so in that case the force will be equal to mg lb. These both forces should be balanced. Therefore mg, that is the weight, should be balanced by the force due to the wire, that is ilb. From here you can find B equal to mg upon m will be equal to 20 into 10 raised to minus 3 multiplied by g, take 9.8 divided by current is 1 and this is also 1. So this will be 0.196 meters. This is your answer. So the formula you are using, there are two formulas. One is weight, that is force, that is equal to mg, and the other one is ilb. Calculate the value of magnetic field. B value you are supposed to find at a distance of 2 centimeter. R is given as 2 centimeter. Convert it to meter. 2 into 10 raised to minus 2 meter. Ampere. Mu naught value is given to you in SI Weber per ampere. So we know that B equal to mu naught I upon 2 pi R. So B will be equal to 4 pi into 10 raised to minus 7 into I, that is 2 into 10 raised to minus 2. Pi cancel. Here 2. 2 also cancel. So B will be equal to just 5 into 10 raised to minus 5. Tesla. This is the correct answer. 5 into 10 raised to minus 5 Tesla. An electron is moving in a speed. V is given 3.2 to 10 raised to 7 meter per second. In a magnetic field, B is given 6 into 10 raised to minus 4 Tesla, perpendicular to its path. So theta is 90, perpendicular theta is. What will be the radium? Radium means radius of the path. What will be the frequency? What will be the energy in kilo electron volt? So I will just give you the formula. It is expected for the students, you put the value and solve. I guess entire solving, if I don't show, that is fine. So because the magnetic field chapter, the sums are very lengthy. So I suppose if I just put the values and give it to you, at least the solving part can be done by you. So I'll just give you the formula and put the value. So the remaining part, it is expected that you do it on your own. So first, to find the mass and charge, everything is given in the question. That is 9.1 into 10 raised to minus 31 into 3.2 into 10 raised to 7 divided by charge value 1.6 into 10 raised to minus 19 into B value. B is 6 into 10 raised to minus 4. So when you solve this, you get 0.03 meter. On solving, you should get this at 0.03 meter, this radius value. Second, you are supposed to find the frequency. To find the frequency, we know that F equal to QB upon the value 1.6 into 10 raised to minus 19 into B value 6 into 10 raised to minus 4 divided by 2 into 3.14 into. So when you solve this here, this value is nearly around 16 or 17. The value is 16.78 into 10 raised to 6 hertz. This will be your answer. 16.7, nearly this answer will be. Energy in keV. Third point is they are asking energy. So kinetic energy formula is Q square B square R square upon 2M. Since they are asking in keV, you will have to multiply that. So 1.6 into 10 raised to minus 90 into 10 raised to 3. Now what did I do here? So see, kinetic energy formula is Q square B square R square upon 2M. You need to convert it to keV. The answer when you solve kinetic energy, only Q square B square R square upon 2M. When you solve this much, you get the answer in joule. You need to convert the joule to keV. So when you convert joule to keV, you do this thing, what I'm doing. 1 divided by 1.6 into 10 raised to minus 19 into 10 raised to 3. So just put the values over here and just do the calculation. You will get the answer in keV. The answer will be in keV. You have converted that value. So this conversion which I have written, okay, this is the conversion from joule to keV. K means kilo. Kilo means 10 raised to 3. And EV means 1.6 into 10 raised to minus 9. An alpha particle is always a nucleus. So please remember, mass of alpha particle is what you are supposed to find here. Obtain the mass of alpha particle is told here. Charge of alpha particle is 2 times charge of proton. This you should know. Charge of alpha particle is 2 times charge of proton. Is accelerated and moves in a vacuum tube with the kinetic energy is given to you 10 MeV. So again you have to convert here. M means mega. Mega means 10 raised to 6. EV means 1.6 into 10 raised to minus 90. So this you are converting into joule. So this kinetic energy will become, I'll multiply this 10 with 1.6, so this will become 16 into 10 raised to 6 minus 19 will be minus 13. I'm writing this kinetic energy like this. On applying a transverse magnetic field, B is given 1.851 Tesla. It follows a circular trajectory of radius 24.60 centimeter, convert centimeter to meters, 24.60 into 10 raised to minus 2 meters. Obtain the mass of alpha particle, that is you are supposed to find. Q square, B square, R square upon 2m. So from here rearrange. So M will be equal to 2 into kinetic energy divided by Q square, B square, R square. So this will be the formula for mass. Just rearrange this. So from here, put the value. M will be equal to 2 into, this will be 16 into 10 raised to minus 36, 2 into 10 raised to minus 19 square. B square is given to 1.851 square into R square, that is 24.60 into 10 to the power minus 2 square. Your answer on solving this will be nearly 6.64 into 10 raised to minus, this will be 27 kg. This will be your answer. 6.64 into 10 to the power minus 27 kg. Approximately, this will be your answer. The two wires are shown in the figure are connected in a series circuit, and the same current of 10 ampere. Same current of 10 ampere passes through both in opposite directions. So you have been given with the diagram in the question. So if you see, the current value is known to us. The current value I is 10 ampere. So the separation between the two wires is 8 mm. Separation, let us denoted by D, that is 8 mm. So that is 8 into 10 raised to minus 3 meters. That is given to us. The length AB is 22 centimeter. Obtain this to find out. Due to the current in wire 2 in the following segment AB of wire 1, also obtain the magnitude of direction of the force on wire 1. So two things you are supposed to find out. One is B, one is F. So first let us find B. B due to wire B, you are supposed to find due to current in wire 2. Here it is given in the question, find the magnetic field due to current in the wire 2 in the following figure. So we know that B is equal to mu naught I upon 2 pi R. So that is 4 pi into 10 raised to minus 7 into I is 10 divided by 2 pi into, here obviously I will take the separation over here. Instead of R, I will write D here. Separation, that is 8 into 10 raised to minus 3. In actual formula, it is R, but here we have taken it as B, so let us correct that. So this will be, again, here it will be 1, here it will be 2. So this will be 20 upon 8 into 10 raised to, 20 upon 8, you can reduce it to 10 by 4. 10 by 4 or 5 by 2, that is 2.5. So I'll directly write this is 2.5 something. This we can write it as 2.5. 10 raised to, the value will be minus 4 on solving. This will is the magnetic field value, 2.5 into 10 raised to minus 4 Tesla. Second thing, they are asking to find the force. So force should be due to two parallel wires, that is given by mu naught I1 I2. Force upon L is mu naught I1 I2 upon 2 pi d. So force you are supposed to find out. So that value will be equal to F will be equal to, I'll take that L to that side. L value is 22 centimeter. Here they have given L value is 22 centimeter. It is 22 into 10 raised to minus 2 meter. So I'll take L to that side. So F will be 7 into I1 I2. Both are 10. I'm taking L at this side. I'm taking L at this side. So this will be multiplied 10 raised to minus 2. But by 2 pi into D value 8 into 10 raised to minus 2. So students, just I've substituted the value. When you solve, you get 5.5 into 10 raised to minus 4 Newton. This is your force value. A very long straight wire carries a current I of 5.2 ampere. What is the magnitude of given? 3.1 centimeter. So convert centimeter to meter. 3.1 into 10 to the power minus 2 meter. Again, B will be equal to mu naught I upon 2 pi R. Same Ampere's law formula. So B will be equal to 4.2 divided by 2 pi into 3.1 into 10 raised to minus 2. So just solve this, you get the value for magnetic field. That is 3.35. Nearly this will be 3.35 into 10 to the power minus 5 Tesla. This will be your magnetic field. Currents of equal magnitude. So I'll take I1 equal to I2 equal to I. Equal magnitude current pass through two long parallel wires having separation. Separation between the two wires is 1.35 centimeters 2 meter. If the force per unit length, okay, F by L value is given 4.76 into 10 to the power minus 2. This should be Newton per meter. There is a correction in the question. This should be Newton per meter. What must be I? I you are supposed to find. Just now we have written the formula ID. So F by L value is given to us. So that is I'll put the value later. First, I'll do one thing. Mu naught I1, I2, I can take it as I, right? So this will become I square. Because same current, the question is telling current of equal magnitude. So same current is flowing into 2 pi d. First rearrange the formula, then put the value. So I can write I will be equal to square root of 2 pi d into f upon L divided by mu naught. So now you put the value. That will be 2 pi into d value. D value is 1.35, 4.76 into 10 raised to minus 2 divided by mu naught, that is 4 pi into 10 raised to minus 7. So you cut this pi and all. When you solve this, you get the answer. So answer will be 56.7 ampere. That will be your answer. Just do the calculation and get the answer. Again, same sum of Ampere's law, B equal to mu naught I upon 2 pi r, B into 2 pi r upon mu naught. So, such type of sums, it is expected students do it on your own. So, B is given as 16 micro Tesla. Micro means 10 to the power minus 6 into 2 pi into R value is 2.4 into 10 to the power minus 2 divided by mu naught value is 4 pi into 10 to the power minus 7. So, again, when you solve this, you get the current value is 1.92 ampere. Next, the magnetic field at the center of the circular current carrying loop of the radius B at the center, which is given to you. This is 6.4 into 10 raised to minus 6 Tesla. Radius is given 12.3 centimeter. 12.3 centimeter, 12.3 into 10 to the power minus 2 meter. What is the magnetic moment M value you are supposed to find? So there's a direct relation between magnetic moment. So magnetic moment formula we know. Magnetic moment is current into area. Okay, so from first you find, see, magnetic field at the center is given. Magnetic field at the center is given to you as mu naught I upon 2r. From here, find the value of current. So current will be equal to B at the center. So that will be 6.4 into 10 to the power minus 6 into 2 into 12.3 into 10 to the power minus 2 divided by mu naught, that is 4 pi into 10 to the power minus 7. So you will get some value. So this value you will substitute in the magnitude square. So what current value you will substitute? The value which you get over here. The current value which you get over here, this value of current, you will put it over here. Right here. Then you will get the answer as for magnetic moment. And the final answer for magnetic moment will be 5.95 into 10 to the power minus 2 ampere meter square. That is the final answer. Current value you find out. So I'm not giving you right now. Just solve it and get the answer. A circular loop of radius 9.7 centimeter. Very, very important and a lengthy question again. So radius carries a current of 2.3 ampere. I is given to you 2.3 ampere over here. And obtain the magnitude of magnetic field at the center. Again, same question. Magnetic field at the center is mu naught I upon 2r. So 4.3 divided by 2 into 9.7 into 10 raised to minus 2. So just solve this. The magnetic field at the center, this will be 1.49 into 10 raised to minus 5. It is expected you log calculation to solve this such type of numerical because that's very important for marks. And the second thing they're asking, it is at a distance of 9.7 centimeters. So distance is x 9.7 into 10 to the power minus 2 meter is given to you. In that case, the magnetic field is given by B equal to mu naught I r square upon 2 r square plus x square raised to 3 by 2. So here you have to substitute the values. All values are given to you. Put the current value, radius value, x value, and solve for mu naught. You will get the answer as 5.26. 10 to the power, that will be your final answer. A circular coil consisting of 100 turns, n is given 100 turns, made up of 100 turns, each of radius is given 8 centimeters. So converted to meter, 8 to 10 to the power minus 2 meter, radius is given to us. If a current ampere passes through it, what will be the magnetic field at the center? Okay, same question, magnetic field at the center. Now here number of turns are given, so mu naught In upon 2r. Only the number of turns you have to multiply, that is the extra thing that is due. Meaning everything is same. 4 pi into 10 to the power is 100 divided by 2 into 8 into 10 to the power minus 2. So the magnetic field at the center, that will be 3.142 10 to the power minus 4 Tesla. Next, for a proton acceleration, a cyclotron is used in which a magnetic field of 1.4 Weber per meter square. B is given 1.4 Weber per meter square is given to us and is applied. Find the time period for reversing the electric field between the two Ds. So time period to reverse the electric field is given by pi m upon qb. This is the formula. by m upon q. So that is denoted by small t. This is the formula. So just put all the values. B value is required. So T will be equal to 3.14 into M value. So it is a proton. Charge of proton 1.6 into 10 to the power minus 19 divided by sorry, that is mass of proton. So mass of proton will be minus 27. Mass of proton will be minus 27. Charge is minus 19. Minus 27. 1.6 into 10 to the power minus 19 and B value is 1.4. This is getting cancelled. This is getting cancelled. So just solve this. You will get the answer at second. That is the time. Next question. A moving coil galvanometer. Very easy formula for a moving coil galvanometer has been fitted with a rectangular coil having 50 turns and dimensions 5 centimeter into 3 centimeter. Number of turns is given 50. Dimensions means area 5 centimeter into 3 centimeter. So this is I can write minus 4 meters square. This is given to us in the question. And the radial magnetic field in which the coil is suspended B is given to us 0.05 Weber per meter square. Magnetic field value is given to us. The torsional constant or the spring constant that is given to us is 1.5 into 10 to the power minus 9 Newton meter per degree. Obtain the current value. You are supposed to find NBA upon K into I. This is the formula. Acha, phase is given to you. Phase is given as 30 degrees. So phi is given as 30. Take this as 30. So I will be equal to K phi upon NBA. So just put the value and do the calculation. You will get the value for the current. That will be 1.2 10 raised to minus 5 ampere. This is your answer. Put the value. K value is given to you. K is given 5. Keep it as 30 only. Put NBA and all the values. You will get your final answer after substitution. Next. A solenoid of length pi meter. Length is given 5 centimeter. So radius will be 2.5 centimeter. Converted to meters. 2.5 into 10 to the power minus 2 meters. Of 1000 turns, number of turns is 1000 given to us in the question. Current of 5 ampere flows through it. Calculate the magnetic field at the site. This is the formula where small n is equal to capital N upon length. Right. So this is the final formula that we've left. Here you have to write that small n is capital N upon L. Okay. Small n value is capital N upon L. So your diameter and radius are not required. Actually, diameter is a dummy data which is given to you. That is extra data. That is not required. So just put the value 4 pi into 10 to the power minus 7 into 1000 to I is 5 divided by length value is pi. So pi getting cancelled. 5 4,000 into 10 to the power minus 7. 1, 2, 3, 4. So this will be 2 into 10 to the power minus 3. Yes. Next, a toroid of narrow radius of 10 centimeter has 1000 turns. Radius is given 10 centimeter means 0.1 meter. Number of turns is given as 1000 turns of wire for a magnetic field B is given to us 5 into 10 to the power minus 2 Tesla given as in the question. How much current is required to pass? I value is required. So in case of toroid, B equal to in case of a toroid. So from here rearrange current will be equal to B into 2 pi R upon mu naught N. So I will be equal to B value 5 into 10 to the power minus 2 into 2 pi into R value 0.1 divided by mu naught 4 pi into 10 to the power minus 7. 1000 turns is 10 raised to 3. So pi cancel and just solve this. You will get the answer 25 ampere is your answer. In a cyclotron, protons are to be accelerated. Radius of these R is given 60 centimeter. So this is 0.6 meters, 60 centimeter. And oscillator frequency means 10 raised to 6. So I can write this total as 10 raised to 7 hertz. 10 into 10 raised to 6 can be written as 10 raised to 7. What will be the kinetic energy? Kinetic energy you are supposed to find Q square, B square, R square upon 2. But B is not given to you. Frequency is given to you. So you will be upon 2 pi m. From here, find the value of B first. So B will be equal to F into 2 pi m upon Q. Put this square. B square will be F square 4 pi square M square upon Q square into R square upon 2 m. Q square cancel. 1 m getting cancelled from here. 2 ones are 2 2s are. So this will be F square. This will be F square. F square into 2. F square into 2. Pi square M into R square. This is your final formula. This is your final formula. Means there is no direct formula. So we have derived this formula. Kinetic energy is you are supposed to find. Kinetic energy you are supposed to find. Frequency is given to you. So there is no formula in which kinetic energy and frequency are there. So there are two different formulas. So you have to merge that two formulas and get the answer. So just put all the values. When you put all the values, you get 7.5 MeV as your answer, mega electron. When you solve, you get the answer in Joule. You will get the answer in Joule. Joule you convert it to E. Next, a wire loop in the form, a wire loop of the form shown in the following figure carries a current I. Obtain the magnitude and direction of the magnetic field at P. So if you see very carefully, there is one straight wire. The magnetic field due to straight wire is this. This is given to us in the question. This is a magnetic field due to which I'm shading here. This is the straight part. So for straight part, the magnetic field is given 2 naught I upon 4 pi r into root. This is given to us in the question. I need to find for the remaining, the arc which you see, the arc which covers an angle of 270 degree. ये जो remaining arc है, circular arc. For the remaining circular arc, I need to find the, just highlight this. This I need to find the, for this arc which is given to us. This is given to us in the question. I need to find it for the remaining. Okay. So for this part, I am supposed to find this part. We do not know. This part is given to us in the question. So that is this. So in that case, so B1, I will rename them as B1 is mu naught I root 2 upon 4 pi r. This is given to us in the question. I need to find B2 and total. Actually, I need to find the total. So first, let us find B2. So what angle do you see? This is 270 degree, right? 2 upon 4 pi r. We know this formula for an angle. 270 degree means 3 pi by 2. So mu naught I upon 4 pi r into 3 pi by 2. I will write, instead of theta, I will write 3 pi by 2 because theta is 270 degree. 270 degree means 3 pi by 2 in radian. So we know this value. So B1 plus B2. So just add the two values. Mu naught I upon 4 pi r into root 2. This was given to you. Plus mu naught I upon 4 pi r upon 4 pi r common. Instead, there is left out root 2 plus 3 pi by, and that is your answer. The remaining three problems are not required as far as boards is concerned. You can skip those three problems. They are very much advanced problems and they will not be answered in board exam. So there is problem number 19, 20, and 21. Negligible chances are there that these three problems will be asked. If you don't do, even that is fine. Just do till question number 18 only, no problem. So you can skip the last three problems.